This is 5-8, applying special right triangles. For 1 and 2, pause the video and check your, hit play when you're ready to check your work. Okay, there's your answers for 1 and 2. For example 3, things get a little bit harder here. So it says simplify the expression 12 over radical 3. We have to rationalize the denominator. If you remember from algebra, the denominator cannot contain a radical. So what we do is we multiply it by itself on the top and bottom, because it's really just like multiplying by 1, so we're not really changing things. But what this does is it cancels out the radical on the bottom, because radical 3 times radical 3 is radical 9. And what's the square root of 9? 3. And up top we get 12 radical 3. Then what you do is you actually just cover up. Don't look at the radical for a second, just look at the fraction so that you can simplify 12 over 3. 12 over 3 is 4, and then you put back the radical. So 4/3. For the next one, you can't have 20 over radical 2. So we are going to multiply top and bottom by radical 2 to rationalize that denominator. What we get when we do that, well, in the bottom, radical 2 times radical 2 is radical 4, and the square root of 4 is 2. So that's why we did that, so that just cancels to 2. And then 20 times radical 2 is 20 radical 2. The next step I said, cover up the radical for a second, don't look at that, and simplify 20 over 2. Well, 20 over 2 is 10, and then put back the radical, 10 over 2. If you take a square and cut it along the diagonal, it creates these 45, 45, 90 triangles where both legs are congruent, and the length of the hypotenuse is the length of a leg times radical 2. So, for instance, if a leg was 2, and this leg would also be 2 then, and then the leg would be 2 radical 2, because you're plugging in the L that we had here was 2. So we get 2 radical 2. What you need to understand is that this is something that you want to memorize, the ratio of these sides. And so some people call it L radical 2. They might call it like X radical 2, X radical 2 instead. And I'll show you how we're going to use that. So special right triangles allow us to find a missing side using these ratios due to the 45, 45, 90 triangle. So here I know I have a 45, 45, 90 because of triangle sum theorem. And so therefore I can use what I know about 45, 45, 90. Across from the 45 is x, and the hypotenuse, even though they're calling it x right now because that's what we're looking for, I'm going to change it to a question mark, that across from the hypotenuse is really x radical 2. So since the x is lined up with the 8, I set them equal to each other. Since x equals 8, I can then substitute that in, and I'd get 8 radical 2. So the value of x, or the thing that we were questioning at first, is 8 radical 2. Here they're wondering what the side of one leg will equal, so the x is in the correct spot this time, I'd say. So since we know that 5 is equal to the hypotenuse, which is x radical 2, then we have a little bit of work to do to solve. To get x by itself, I divide both sides by radical 2. Well, I can't have 5 over radical 2. I'm going to rationalize that denominator by multiplying the top and bottom by radical 2. On the bottom, we get 2, because radical 2 times radical 2 is radical 4, and the square root of 4 is 2. And up top, we get 5 radical 2. And then you see if you can simplify that. So ignore the radical, and you get 5 over 2, which is already simplified. If you want to pause for the now you try, and you feel like you're ready to try it, that's great. If not, you can listen right now. Okay, across from the 45 is our x. So x equals 7. So even though this says x, it's really not x. Across from the 90 is x radical 2. So since I know x is 7, I can just substitute that in to get 7 radical 2. Okay, and the last one, our legs are x and x, and our hypotenuse is 3. So I can set the 3 equal to our hypotenuse value, which is x radical 2. And again, to isolate x, I would divide by radical 2 on both sides. Can't have that, so we're going to rationalize the denominator. 3 over radical 2, we're going to multiply the top and bottom by radical 2. So that on the bottom we just get 2 and 3 radical 2 up top. I cover up the radical, see if I can simplify, and I can't. So that's my answer. Okay, Jane is cutting a square material for a tablecloth. So this is a square. The table's diagonal is 36 inches long. So I already know that's my hypotenuse, so I know that that's equal to x radical 2 before I even get too far into this. She wants the diagonal of the tablecloth to be an extra 10 inches, so it will hang over the edges of the table. So she needs to add 10 more to that, so it's really 46 inches. What size square should Jana cut from the fabric to make the tablecloth? And round to the nearest inch. So what we're saying is, how long should this piece be by that piece? So since we know 46 equals x over 2, we can divide both sides by radical 2. 46 over radical 2, we're going to rationalize that denominator. We end up with 46 radical 2 over 2. And then simplify that, you get 23 radical 2. If you calculate this in your calculator, you'll get x to be about 33 inches. So that 23 radical 2, it's really multiplication. You can type 23 times radical 2 in your calculator. This is the same idea, except it's a 30, 60, 90 triangle. So across from the 30 every time we'll have x, or s in this case. Across from the 60 we'll have x radical 3, and across from the hypotenuse will be 2x. So I'm looking at my first x, it's across from the 30, so it really is an x. And I know that we were provided with the hypotenuse, so let's start there. Since the hypotenuse equals 2s, or 2x, then I can solve for x by dividing both sides by 2, and I get 11 equals x. So the one across from the 30 has to be 11. And now that we know x, we can plug that into x radical 3, which is the one across from 60. So we end up with 11 radical 3. Okay, so I was provided the 15, which is across from radical 60. So I'm going to set 15 equal to x radical 3. Divide both sides by radical 3. Rationalize the denominator by multiplying top and bottom by radical 3. And I end up with 15 radical 3 over 3. Simplify that and we get 5 radical 3. So I know that x is equal to 5 radical 3. That would be the one across from 30. And the y, the hypotenuse, is going to be equal to 2x. So 5 radical 3 is my x times 2 for 2x. I end up with 10 radical 3. Okay, this is the 30, 60, 90. Since 16 is the hypotenuse, I know that it's equal to 2x. If I solve that, I get that x equals 8. So across from the 30 is 8. And in the y position, that would be x radical 3, since it's across from 60. So I just plug the 8 into the x, and I get 8 radical 3. Okay, here we're starting with 11. It's across from 60, so I put 11 equals, across from 60 is x radical 3. Divide both sides by 3. Rationalize the denominator by multiplying top and bottom by 3. You get 11 radical 3 over 3. Since x equals that, and I know the hypotenuse is 2x, then I'm going to have 2 of these. 2 11 radical 3 over 3s, which calculates to be 22 radical 3 over 3. So the y value there is 22 radical 3 over 3, and the x value in this case was 11 radical 3 over 3. Here's my work for example 4. I knew x was 10, so I just plugged it into x radical 3 so I can get what was across from the 60. So I get 3. And our answer for the now you try will be no. I got about 5.2 centimeters. 5.2 centimeters. And no, it won't fit.